Well, hello and welcome you to Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you today. So you step into my virtual classroom. It won't be a lecture today, but it will be practice problems, a big review about linear equations and functions and slope-intercept form and point-slope form and standard form, and what makes one linear versus not, and what are solutions to linear equations and all that good stuff. Now, as you know, if this is a bigger overview, it would probably be a longer video. I want to try and save a little bit of time on it by doing these problems as if you've already heard it before. So there were a couple videos that I've just done of just a couple lecture videos on this stuff. So assuming that you've heard that, or you've done practice problems like these before and you've learned it at some point, I'm playing under that assumption here. So I think that'll save a little bit of time. But in turn, I do want to make up some time with that by saying how many different ways you can go about doing a problem, if I feel like it's beneficial to the cause, or if I feel like that flexibility is something that you're willing to work with here. So as I jump straight into this right now, I'm going to have us look at question number 1. Which of the following are linear functions? We have up to letter n, which is I think 14 different problems to do, just for one particular problem in itself. And so yeah, let's just start talking about it right now. Number 1, which of the following are linear functions without graphing it? Granted, some are graphed and we can answer that question pretty quickly. But if you have an equation, how do you know if something's linear or not? Now, the way I spoke about it is if we can make our variables to be of the first degree, of degree 1, and they have an exponent of 1, and they're not inside a function like an absolute value or a radical, or they're not inside a denominator. You know, another way I can say it now, because I talked about it before mentioning standard form, if you can write your equation in standard form, then it's a linear function as well. Standard form meaning your ax plus by equals c. I'm going to go ahead and leave that at the bottom of the screen here, and I'll show you what some of those rewrites look like, just to kind of say, in fact, yes, they are. All right, so if I say yes, that means it's linear. If I say no, that means it's non-linear. By non-linear, I mean not one straight continuous line. X squared plus y squared equals 9. No, this is non-linear. In fact, this is the equation of a circle with a radius of 3, just so you know. These x and y variables are of degree 2, not a linear function. Y equals 4 over x. Although this is to the first power, this x may be to the first power, but is in the denominator. No, this would also be y equals 4x to the negative first power, not a positive 1 there. This is called a rational function. 8x minus 3y equals 12. Yes, this is linear. This is actually even in standard form. Ax plus by equals c. Straight up, makes a line. Y equals negative 5/7 x plus 4. Yes, this is slope-intercept form. If you want to see standard form of this, it would be, multiplied by 7, it would be 5x plus 7y equals 28. Conversions, we might be doing conversions later. Y equals 2 root x plus 3. No, this x is not of degree 1 because of the radical. In fact, this x would be to the 1/2 power. These are things that I might be mentioning to a group that hasn't done these kinds of things before. I'm exercising the bigger purpose of, not that you have to know that, but that's what they actually are. This one is, it will probably look like a graph like this, only it goes upward. So y equals 2x. Yeah, this is slope-intercept form, so this is linear. A y-intercept of 0, of course. You don't see it, but it's a line. 4 times the absolute value of x plus 2. Now, absolute value graphs, I'll let you know right now, it does look like a V. An absolute value graph looks like that. Is it linear? It may make two straight line components here, but they are both what are called rays. A is one thing that goes indefinitely in a single direction. No, this is non-linear, even though it makes two straight line portions. Same with this thing right here. It goes straight and straight and straight and straight, but it's not a line. This is non-linear for H. For I, clearly not a line. It's a curve. For J here, clearly a line. And even though they don't draw arrows, this thing goes on forever. Obviously, the graph ones are probably the easiest to mention, linear or nonlinear. For K and L and M and N, we now have tables, and for something to be a line, it needs to have what's called a constant rate of change. Basically, it needs to have a slope. and something that's constant when we do it. So for x, as we increase by 2 each time, we have to make sure that y increases by the same amount each time, by 3, by 3, by 3. Indeed, yes, this is a linear function with a slope, by the way, of 3 over 2. Rise 3, run 2. L, so different colors, so we don't get color blindness here. Plus 3 on x each time. And on y, we go plus 2. Uh-oh, plus 4. We've broken it. Even though there's a plus 2 here, this is 2 over 3. Suddenly, this becomes 4 over 3. It's changing probably like maybe this one is here. No, this is non-linear. Okay. Part M, looks like we have to fill out some information. Lindsay has been turned into a zombie. Tomorrow, she will turn 2 more people into zombies. The next day, each zombie turns 2 more people into zombies. The following day, each zombie turns 2 more people into zombies. Lindsay's turned into a zombie. Let's say that's day 1. She is one of them. I think that works out. She turns 2 people into zombies. We add 2, and we get 3. Now it says the next day, each zombie turns 2 more people into zombies. It didn't say only 2 more people were turned into zombies. Each person. There are 2 people here, and each person gives off 2 zombies. That's 2 times 2, which is 4. Clearly non-linear, as you can see right here. So no, but I want to continue this. The following day, each zombie turns 2 more people into zombies. So, you know what? I said this one wrong right here. Hang on a second. There weren't 2 people. That was day 2. What is this? There were 3 people. 3 people turned 2 into zombies. That's plus 6. Still a no. My point remains. That's 9. And now there are 9 people, which each turned 2 more people into zombies. So plus 18, which is 27. It looks like instead we're tripling our value. 1 times 3 times 3 times 3. So non-linear. No, instead it's exponential. And finally, part N. Jack gets turned into another kind of zombie. The next day, he infects two people, turning them into zombies. These zombies are not able to turn people into zombies, but each day Jack turns new people into zombies. Okay, so only Jack is doing the zombie turning. So there's 1 zombie right here as Jack. He turns 2 people into zombies here. Those people do not. Jack does another 2 people the next day, and another 2 people the next day. So this one appears to be linear. As the days go up by 1, these go up by 2. Yes, this is linear. All right, that's a fun bit. I'm just going to go ahead and move straight on forward because, time. Determine the slope and any intercepts for each line. All right, so as far as slope is concerned, what you want to do is find 2 points that your graph definitely goes on. What I mean by that is like these crosshairs, like this one right here. Make sure that your line definitely goes on one of those, and then it'll hit. For example, my graph does not hit this dot right there. It does definitely not do that. But it definitely does for me right here. And it definitely, that's kind of bright, huh? And it definitely does for me right here. I only need to pick 2 to make a slope because it's a constant. And what I want to do is find its rate of change. I'll show you a couple others where it does hit. These points right here. Now I'll do the slope in a second. Well, the 2 points that I found actually were the x and y intercept. So why don't I just jump straight into that? My x-intercept is -2, 0. If you put -2, you'll be fine. I want to keep re-emphasizing the point that y is 0, though, when I do this. And the y-intercept will be 0, 3, right there, where it crosses the y-axis. And, to find my slope, I can choose just those 2 points and make this happen. I have to know my rate of change, how much y increases, how much x increases. And this is a positive slope. We're going up and right. So it is a positive slope here. We rose 3, we ran 2, the slope is 3 over 2. Now, as I said, it doesn't matter which 2 points that I choose. I could have chosen these 2 points and go up 3 over 2, or these 2 points and go up 3 over 2, these 2 points and go up 3 over 2. Now, you might say, Mr. Robinson, what about if I chose this point all the way down here, and this point all the way up here, and I chose its slope? I say, how much does this rise and how much does the run? Aren't those numbers different? Well, the rise and run numbers are different, but the inherent value's not. I'm going from -6 all the way up to +6. That is a rise of 12. And my run goes from -6 all the way to 2. That is a run of 8. You want to know what 12 over 8 is? If you divide these by 4, you get 3 over 2. Divide by 4, divide by 4. This 3 over 2 is just the reduced fraction form of what you do. So you can choose any 2 points you want, just reduce the fraction, and you get back to your slope you need. Like I said, it was a positive slope. Part B, actually there is no x-intercept for, yes, there is no x-intercept for this one. I should get rid of that. It's just a flat line. See, it does not cross the x-axis. So, there you go. The slope, pick any 2 points it crosses through. I don't really know how much I want to say about this. I've mentioned it before. Horizontal line is a slope of 0. I rise 0, and even here when I run 1, 2, 3, 4, 5, 6, 7, 0 over 7 is still 0. Yeah, I recommend that you reduce that to 0. You don't leave it as 0 over 7 or 0 over 1 or anything like that. No rise, all run, slope of 0. Flat line. This does have a y-intercept. It does cross at 0, -5. And there you have that problem. Letter C for number 2. The slope here, again, pick 2 points. Why don't I just pick the 2 points that make the x and y intercepts? Why don't you, right? Why don't we pick the points that, let's kill 2 birds with 1 stone. Let's find our x and y intercepts at 1, 0 for x, 0, 2 for y. The intercepts, that is. And the slope, we choose these 2 points to see how much we go down and how much we go over. Notice we are going down as we go to the right. That means this is a negative slope. I'm going down 2. That is a -2. And I ran right 1. So -2 over 1, by the way, is also -2. Is it absolutely necessary you need the -2 instead of this? No. But you got to know that these two are the same thing. Now you might ask, what if instead of going down 2 and right 1, what if we went left 1 and up 2? Well, that's fine. Just make sure you think about going left as negative. If right is positive, left is negative. That's a -1, and now as I go up, it's a +2. 2 over -1 is the same thing as -2 over +1. It's still a -2. So it doesn't matter which way you do it, just make sure you note your sign. Downward slope. All right, letter D, we have a vertical line right here. It only has an x-intercept, as I made certain of to write. The x-intercept right here is -3, 0. And the slope, it's a vertical line. All rise, no run. Even if I choose these 2 points right here, I rose 2, but ran 0. Division by 0 is undefined. This is an undefined slope. And again, I shouldn't really be putting these numbers anyway. The whole point is vertical lines have an undefined slope, straight up. Horizontal, 0. Vertical, undefined. Okay. Number 3, determine the slope and y-intercept from each equation. One equation does not have a y-intercept. Okay. We don't have the graphs, and, you're not supposed to necessarily make the graphs here. Yeah, I said that I'd show different ways that you can do a problem. Yes, I could graph these, and you could graph these. And if you want to plot a table or go based on the form, go ahead and do it. But you can do it from the equations. We can get the slope and y-intercept from the equations, and I want to make use of the equation forms to tell you that. See, this is y equals mx plus b form right here. We are in slope-intercept form. What's great about that is that m represents your slope and b represents your y-intercept. M, -2/5, is your slope. By the way, I get this a lot. A lot of people put the slope as -2/5 x. X is not your slope. X is affected by your slope, but x does not belong there. It's just -2/5. Okay? X is a variable that increases your values here so much as your y values increase or decrease. The y-intercept is the b value right here. It's a -1. If I leave it as a coordinate pair, it's 0, -1. If you just write -1, you're not wrong, but you got to know which one the point is. Okay, it is a y-intercept. Y equals 3/2. This one's a little interesting because I do not see, is this y equals mx plus b form? You can makeshift it into that. If 3/2 isn't multiplied by x, then 3/2 must be the b value. So what's the m value? If we're adding something with x to it, but I don't see the x, the coefficient must be a 0. 0 times x would make that go away, and you would just get y equals 3/2. Yeah, see, this is a horizontal line right here. If you learn the horizontal lines, you'll know horizontal line right there, and therefore 0 slope. And I can show you right there, the slope is 0. The y-intercept indeed, though, is 3 over 2, or 0, comma 3 over 2, as you leave it as a coordinate pair. I'll always try and leave them as coordinate pairs, if that's cool. Y equals negative 4x. Is it in slope-intercept form? You betcha. Y equals mx plus b. Here's my m and my x, and my plus b seems to be missing, but just like the last one, it's missing because it's a 0. If I do plus 0 right here, that reveals the true nature of my y-intercept. You see, my slope is negative 4. It's negative 4 because it's m. For your sake, I'm going to write it as a negative 4 over 1. So again, for the practice, we note that when we graph this, fall 4, run 1, things like that. And I said fall because it's negative instead of rise. Y-intercept is 0, or in this case, 0, comma 0. It's at the origin. All right, part D, x equals 5. You know, I said that y equals 3/2 without the x in it is a horizontal line. X equals is a vertical line. And again, I have a lecture that goes over that thing, but this is a vertical line at no less than x equals 5. I'll show you what the graph looks like. It looks like this. Here's 5 for x. It's a vertical line that goes like that. There's an x-intercept of 5, comma 0, but they're asking for a y-intercept. Never crosses the y-axis because it's parallel to it. They said one equation does not have a y-intercept. This is the one. There is no y-intercept. The slope, like a vertical line is undefined. No slope, no y-intercept. How highly unique this equation is. Y equals x. Is this slope-intercept form? Well, y equals negative 4x was slope-intercept form, so why can't this be? Just put a little plus 0 there, I think will be good. And correct, it is plus 0. But we got to find that slope. There's no number written in front, but that's because it's implied what it is. This is a 1 that goes in front of that x. And 1, a slope of 1, means also 1 over 1. You can write 1. You're fine if you write 1. But y-intercept of 0, 0, once again at the origin, just like the part C. In letter F, you know, don't get hung into the fact of thinking, oh, this is my y-intercept and this is my slope. No, that's true when you're in slope-intercept form, when you have y by itself. The very nature of y equals mx plus b is such because it is y equals, not 3x minus 4y equals. So if you want to figure out this slope, you have a couple options, graphing them as 1, and I'm not going to turn you away from it. But as far as this, what if we rewrite this into slope-intercept form? What if we get y equals mx plus b, which means getting y by itself, the x term first, the constant second? Let's try that. Let's get y by itself here by subtracting 3x from both sides. And a couple common things that I'm seeing people do quite often is they're ignoring the negative when they bring this down. They just say 4y, but instead it's negative 4y. Make sure you note that. And the other thing that they also tend to do is they tend to combine like terms here. These terms are not alike. 12 minus 3x isn't 9. It's not 9x. They don't combine. Negative 3 is one of the terms. Negative 3x, excuse me. And 12 is the other term. And as I want mx plus b form, I'll make it look like this. But I'm not done. I still have to divide everything by negative 4. I have to get y by itself. So it's important that we have that negative because we have to make sure that all of these signs change. And if you divide one thing by negative 4, you divide everything by negative 4. So that's gone. You just have y here. My picture's cutting it off a little bit. You have y there. And then negative 3 divided by negative 4 is positive 3 over positive 4. And don't get too hung up in asking what 3 divided by 4 is. You can leave a slope as a fraction, as I've done for all of them, except for 0. And you're probably better off when it comes to graphing. 12 divided by negative 4 is negative 3. That is the slope-intercept form. That's going to be very helpful for me, slope-intercept form, to find my slope in y-intercept. My slope was not 3. It is 3/4. Yes, there's a difference. Big, big difference. One is 4 times more than the other. Negative 3 is your y-intercept. It's not 12. That's a huge difference. So that is 0, comma negative 3. And again, you could graph that by finding the intercepts and then calculating slope and seeing the y-intercept that way. Either way would work. All right, I'm going to go and move on. Number 4, we got a word problem, some situation stuff, and we have to interpret slope, y-intercept, and x-intercept alongside this. Keep in mind, note what the y and x-intercept mean. Y-intercept being, I'll highlight the things right now. Y-intercept being this guy, x-intercept being this guy, and of course slope we can calculate and make happen. A chemical company buys a machine to process a solution that plans to sell. The following graph, sorry, I'm listening for, I'm expecting deliveries. So if I ever pause the video, if you ever hear a doorbell, or if I stop unexpectedly, you know why. But I'll edit out me leaving to grab a package. I don't want any packages stolen. We might get some more. The following graph shows the profit that the company expects to make as a function of the volume of solutions that the company sells. So it's processing some sort of chemical solution here. It comes in volume. Based on the volume that it sells, it expects profit. Calculate the slope, y-intercept, and x-intercept. Then interpret. Interpret each in the context of the situation. Fantastic. I am more than pleased to do so. And I'll do them in order, but based on these 2 points that I do have, I'm going to go ahead and calculate for you a rise and a run. Now, one thing about this rise and run right here, and you have to be very careful about this, you might be bent into thinking this is going up 1, 2, 3, 4, 5, 6, and over 1, 2. But the scales are not so simple as 6 and 2 because these scales are different. Every increment here looks like it's 50, and every increment here looks like it's 20. So if I go up here, I mean, I'm going from negative 300 to 0, so I'm going up 300. But if I went 6 50s, 6 times 50 gives you that 300. And if I go over 2 20s, that's going over 40. So I'm going up 300, and I'm going over 40. And as always, we should look to reduce a fraction when we can. This is 30 over 4, and if I divide those by 2, that's 15 over 2. So the slope is 15 over 2, and now we must interpret this thing in context. And notice that they give us, they give us units for these things here, liters in profit. 15 is a rise, 2 is a run. And I can leave this as this fraction right here, and this is the most reduced that you should expect to do other fractions. I'm going to give you 2 of them so that the interpretation might have a better sound to it, even though this will be a decimal. I'm going to give you 7.5 over 1 as well. I want you to hear both of them. This is what's called a unit rate. This is what's called a simplified fraction. So the interpretation, and I feel like typing this one out here, so I'm going to go ahead and get that set up for you. The interpretation is, as we rise 15 and run 2, 15 is in profit, I assume in dollars. 2 is the run for liters, for the volume right here, in liters. So every time that I run 2, every time that I increase 2 liters that I sell, every time that I sell 2 liters of chemical solution, for every 2 liters of chemical solution sold, the company expects to make $15 more of profit. I assume it's dollars. Maybe it could be 1,500. I don't know. But it could make $15 more of profit. Okay. Now that is the solution, or that is the, I don't want to say solution because solution's right here. That is the answer to this one right here if I'm talking about the green version. And that's fine. That's generally the answer that I would expect to get. But I like to think of the for every one sometimes. You know, like we don't say like we drive 15 miles in 2 hours, or I guess that's slow. We walk 15 miles in 2 hours. That might be a lot. You run. You would say you ran 7.5 miles per hour or something like that. So what if I had the other version of this thing? If I interpret it the other way, 7.5 per 1, I would say that every liter sold, every liter of chemical solution sold. Package. 1 second. Okay, and we're back. Sorry, I did get some packages. All right. Where was I? Slope. Okay, every liter of chemical. Okay, so I had the 15 over 2 here. Every 2 liters of chemical solution sold, the company expects to make $15 more profit. So every liter of every 1 liter, I'm going to use 7.5 over 1. Every time I sell 1 liter of chemical solution, I profit $7.50. Yields a $7.50 profit. You know, just that unit rate kind of helps in some circumstantial ways. The whole point is like slope-based things, so that works. All right, y-intercept right here. Now remember, it doesn't just represent profit. It represents profit at a specific instance or moment. The y-intercept very specifically isn't just negative 300, it's negative 300 when x is 0. So the interpretation here, the thing we have to make sense of, is just describe the point. What does the point tell you there? And what this point here tells you is, let's use red. Sorry, I want to change my color. What this point tells you is that before the company is $300 in debt. It's good that I used red, I guess. Company's $300 in debt when they had sold 0 liters of chemical solution. What's funny is I'm a great typer anytime that I'm not shooting a video. I don't know why when I shoot a video I have the most typos and the slowest writing. The x-intercept is 40, 0, right? So that's that blue dot right there. And the 40, 0 has a different interpretation, of course. What this thing says is once you sell 40 liters of profit, or once you sell 40 liters of chemical solution, you have made $0. Congratulations. No, but that's a good stepping stone because you're out of the red. The company, see, look at my typing. The company breaks even at, look at this, at 40 liters of chemical solution sold. So breaking even, I think the reason is because I'm talking as I'm typing. Breaking even means that you're no longer in the red and you're starting to actually make positive profit, which is a good thing. See, you spend $300 on that machine, I guess, and then maybe on the liters that you actually made or something like that. But now you start making profit, which is good. Now it takes 40 liters to make it happen because you make $750 per liter sold, right? Or 300 after 40. Okay, so there's that problem there. All right, so, we've done a couple problems now so far where we've been working on looking at what's linear and not, talking about the slope and y-intercept, and now we're actually going to be doing some graphing for ourselves. All right, not just looking at graphs, but now we got to get into some more. So starting with number 5 here, graph each equation. They're all in slope-intercept form. They're all in y equals mx plus b form. And I'm not going to dodge using that. I'm going to go ahead and go straight into that. I'm going to take advantage of having it. In slope-intercept form, what you have always is a slope and a y-intercept. My slope in this case is 4/3, and my y-intercept in this case is -2, but specifically the point is 0, -2. Some people say, let's start at -2, and they do one of 3 things. Either the correct one, or the incorrect one, or the other incorrect one, where they think that both of them are -2. No, the y-intercept, it's called slope-intercept form. They should call it slope-y-intercept form. The y-intercept is -2. When x equals 0, y equals -2. Notice how that goes away when x equals 0. When x is 0, y is -2. When y is 0, x isn't necessarily -2. It could be, but not for this problem. All right, 4/3 is my slope. Rise 4, run 3. Up 4, nice clean graphs. Over 3, plot a dot. Up 4, over 3, plot a dot. Now what I'm doing right now is I'm giving myself a solid foundation for where to draw my line. Now I've done 2 over this way. I've run out of room. And now I'm going to go down and left. And keep in mind, as long as I go negative for 4, as long as I go negative for 3, I'm still doing a positive slope. All right, this is still up and to the right, so still positive slope. Now remember, the points that I found are the easiest points for me to put in this line. These are not the only points on the graph. That's why we make a line, because the line tells you all the different points that you can be on here. It's not just these ones right here. These are just the only ones that give us integers for both of them. But all these other points in between, including my x-intercept, the one that I said was not -2, my x-intercept, probably at 1.5, is another point that's on this graph. I skipped it when I plotted the points, but I make my line to make up for that fact. All right, so that's the first one, part A. Part B, y equals -1/2 x plus 1. We have a slope of -1 over 2 and a y-intercept of 0, 1. Of course, that's where we're going to start, 0, 1. Now that the slope is -1/2, we're going to be going down and to the right. Okay, that's not going to be my line, I'm just telling you. So that means that as we go down 1, we go right 2. Remember, a negative divided by a positive is a negative. And down 1, right 2, and so on and so forth. And now at this point, if I go up 1, that's fine as long as I go left 2. I'm sure I talked about this in my video. I'm nearly positive I did, because that's what I would have talked about. I would have brought that up. So we continue that, we create that graph, and there we are. Drawing the line through that is all that's left, and boom. All right. The last one, y equals negative 2x plus 4, because my face is in the way. I'm going to go ahead and do it right above it. So the slope is negative 2. Now, negative 2 is also negative 2 over 1. You don't just fall 2 and don't run at all. You have to still run that 1 right there. Your y-intercept is 0, 4. All right. So I'm going to start at 0, 4 right here, and that down to right 1 will apply here. My rise over run is up negative 2, which is down 2, and right 1. And I always plot as many points as I can. How many points do you need for a line? Just 2. For precision's sake, how many points should you plot for a line? As many as you can fit. If you could only choose 2 points, which are the best two to choose for most precision? The 2 farthest points away. And I say that I'm not going to get too deep into it. But if you could choose the 2 farthest points away, that'd be best. For fastest sake, which 2 points should you choose? In some cases, the intercepts. And that's going to jump into these problems right here. Number 5, D, E, and F, these are all written in standard form this time. Now, I have 2 ways that I can graph these, and I promised that I would do that, or at least give you the idea that you can do this more than one way. You can graph out of standard form, or you can rewrite this into slope-intercept form, and then graph it that way. I'm going to start with the standard form, and I'll confirm with slope-intercept form afterward, okay? By slope-intercept form, I mean rewrite this into y equals mx plus b. Now, how do we graph out of standard form? Because I told you before, this is not the slope and this is not the y-intercept. But how you graph out of it is you use the intercepts. We got to find the x-intercept, and we got to find the y-intercept. Now, the x-intercept is going to be the value of x when y equals 0. I substitute 0 for y in my equation. Negative 5 times 0 is 0. So this entire term goes away, and I just have an equation that says 3x equals 15. If 3x equals 15, then that means x equals 5. So the x-intercept is 5, 0. That's my point that I plot. The y-intercept is going to be the value of y when x equals 0. So if I substitute 0 for x, 3 times 0 is 0, and 0 minus 5y is negative 5y. So here I get an equation that says negative 5y equals 15, and if I divide both sides by negative 5, I get y equals negative 3, or that y-intercept of 0, negative 3, and that's right down here. Now 2 points make a line, as I said, so I can now draw my line. I'm like allowed to now draw my line based off what I have here. So I'm gonna nice first take on that one. Not bad, maybe not perfect though. Now let's confirm this one. What if I rewrote this into slope-intercept form instead? What if I take this and I do the steps that I need to get y by itself? I'm going to go ahead and have, I'll rewrite this again. 3x minus 5y equals 15. If I subtract 3x from both sides here, remember these two will not combine. I'm going to get, don't forget the negative, negative 5y equals negative 3x plus 15. Now if I divide both sides by negative 5, I'm going to get positive y equals positive 3/5 x. Negative divided by negative is a positive. 15 divided by negative 5 is negative 3, so minus 3. So here's my slope-intercept form. I have a slope of 3/5 and a y-intercept of negative 3. Is this the same? Y-intercept of negative 3 indeed is the same right there. A slope of 3/5 means rise 3 and run 5. Same points? You betcha. Those were both the intercepts even. Maybe that would have been faster. Down 3 over 5. And I'm saying that sarcastically. I think this is incredibly fast to do by setting these equal to 0. In fact, I think I wrote more work than I needed to. It's all about that scribbling out stuff. It just depends on the problem that you have. So anyway, that one pans out. Looks like all's good. Letter E, x plus y equals 3. I mean, to find the x and y intercepts here, guys, set the other equal to 0. There's not much to solve for. Set y equal to 0, x equals 3. That's 3, 0. We're there. Y-intercept, set x equal to 0. Whoopsie, I guess I can't do that. Set x equal to 0, y equals 3. Just like that. So now you have 0, 3. It's that point there. You know what's interesting about standard form, and I have trouble with this a lot, is I couldn't tell you off the top of my head what this graph would look like. Meaning I have to do this to figure it out. See, all the numbers are positive, but look at our slope in the end of this thing. It's negative. It's going to go downwards here. So, you know, I always have trouble with that. I couldn't look at those. Obviously, if I practiced it, I could. But I couldn't look at these off the top of my head and tell you, hey, that's what that thing's going to look like. I guess now I know that all of them are positive. It's going to have a negative slope because they hit these positive things here. But it's just something there that's like, that's why I don't like standard form. I couldn't tell you off the top of my head what that graph looks like. If it's sharp, if it's negative, if it has this y-intercept. I'm not fast enough for that, even still. Okay, letter F here. This time I'm going to give you the intercepts, but I want to say it mentally to show you that it is a fast process. By the way, I didn't rewrite this in slope-intercept form. This would have been y equals negative x plus 3. See if you can confirm that on E. Okay, on F, once again, get x and y by itself. See if you can visually hide them. Cover it with your finger. Go ahead and let's get the x-intercept by setting y equal to 0. Cover it. It's gone. It's gone. It's not, fine, I'll cover it. 2x equals 4, x equals 2. X equals 2 when y equals 0. For y-intercept, set x equal to 0. 4y equals 4, y equals 1. I knew it was going to have a negative slope. We just talked about them both being positive. So there are those. I want to go ahead and get y by itself on this one too after I draw the line. I'll do your slope-intercept form to help you out a little bit. There's my line right there. Not bad. All right, so let's get y by itself on this in case you like slope-intercept form more. Subtract 2x from both sides, and we get 4y equals negative 2x plus 4. Divide everything by 4, and we get y equals... You get negative 2 over 4. Now that reduces to negative 1 over 2. So that's negative 1/2 x, and then plus 4 over 4 equals 1. So negative 1/2 x plus 1. Start at 0, 1. That's your y-intercept. And what do we do? Down 1, right 2. Down 1 over 2. Boom, there's your intercepts. Down 1 over 2. Down 1 over 2. Up 1, left 2. Up 1, left 2 if we go this way. And you can see where my line wasn't perfect. That's why I said for precision's sake, it's better if you get more points or the 2 furthest away points. Okay. All right, so those are 6 graphs based on slope-intercept form and standard form. You know, I'm not going to be graphing point slope form here. There are some problems where you're going to be getting, I think it's coming up right now. I'm not going to graph based on point slope form, but I will write some things in point slope form for you. Write an equation for the line in the graph. All right, so for these, choose which form you want to do. I'm not going to do standard form because standard form I have to do a lot of conversion to get there, and there's no benefit for me that's going to like help. I think y equals mx plus b is fine, slope-intercept form, because it crosses the y-axis in a very neat spot. The y-intercept here is 0, 3, or the b value, very specifically, is 3. To get your slope, just like we did before, pick another point on this graph that it definitely crosses through. I'll go ahead and do this one. And we see how much it goes down and over from one value to the next. Looks like we fall 1, and we run 2, so the slope is negative 1 over 2. That means that this equation is y equals negative 1/2 x plus 3. There is more than one answer to this. If you did use point slope form, you'd have a different appearance, but you would have the same graph. If you used standard form by converting this, I'll tell you what standard form is. It's going to be x plus 2y equals 6. How do I know that? Because I've done math a lot. But I multiplied by 2 and added that over. So that's the standard form. Point slope form, you can pick another point and do it. I'm not going to do it on this one because these next two problems look very point slope formy. And I'm just going to go ahead and I'll answer it in point slope form, and then I'll show you why slope-intercept form might help you for something here too. There's more than one way to do this, but I'll save a little bit of your energy. Write an equation for the line with slope equals 5 that passes through the point negative 2, 4. All right, I'm going to do point slope form right here. And the reason why I'm going to do it is because I have all of the information that I need to simply substitute it into there. Point slope form is the weirdest looking, I do agree, but it is not without its benefits. It still has something going for it. x1 and y1 are the two known points that you have, is the one known point that you have, but the two portions of it in here, and m is your slope. My slope is 5, my x1 is -2, my y1 is 4. And then you write your equation, you keeping the y and x here and substituting the rest. So my answer to this is going to be y minus, my y1 is 4, so it'll say y minus 4, equals 5 is my slope, times x minus -2. That will become plus 2 there. That answer is fine. It is valid. It has use. I could graph from this. I could use that. Technically, what I would do is take this, make the information out of it, and graph it. But we're not going to graph point slope form. Write an equation for the line that passes through 3, -1, and 6, 5. Okay, now I'm going to use point slope form again for the very reason that we are given points to graph from. There's a lot that I'm going to say on this problem, though, so give me some time for this. To use point slope form, though, you don't just need a point, you also need the slope. So in order for me to get slope, I have to calculate it somehow. One way we could do it without a graph is by using y2 minus y1 over x2 minus x1. In other words, use these coordinate pairs right here, x1, y1, x2, y2, and go ahead and do a subtraction. What is your change in y and your change in x? y2 is 5, y1 is -1. We do 5 minus -1 over x2 is 6, and x1 is 3. Doesn't matter which order you write these, as long as if you choose y2 for here, this better be x2. Minus a negative is plus, 5 plus 1 is 6, 6 minus 3 is 3, and 6 divided by 3 is 2. So the slope here is 2, or 2 over 1, if you want to reduce it straight up, because you knew if you graphed this, that's what you would do. I'm just going to go ahead and write 2 for the equation. So the slope is 2. Now, before I write the equation, I want to show you another way that you can be doing this. If you do draw as a graph, and I don't mean a very detailed graph. I don't mean something like this, which, by the way, I could use this graph paper to do it too. But if I just draw the roughest graph you've seen, okay, and if I plot these points, where's 6, 5? Oh, it's 6 over and 5 up. There it is, 6, 5. See, I'm not being particular about it. I'm just guesstimating its spot. And 3, -1, all that I have to care about for 3, -1 is that 3 is left of 6 and -1 is underneath 5. And it's all about, like, a count. What did we do for this other one? How much did it fall and run? Okay, well, how much does this rise and run? I'm finding the slope between these 2 points. So I don't have to, like, count, but I'm asking how much do we go from -1 to 5? That's going up 6. How much do we go over from 3 to 6? That's 3. And clearly the slope is positive. So slope, once again, is 6 over 3, which is 2. There's more than one way to do that. I like the when in doubt, draw it out stage. It confirms that you put things in the right direction. You remember to subtract a negative, because here you might have just done 5 minus 1, way different answer. And that you know which sign it's going to be. It's, I like that quite a bit. Sometimes I'll just do it in my head. This one lends to a lot of mistakes, and it lends to memorization. You want to know what you're doing when you're trying to find the slope of a line. But see, we're not done, and here's the other reason why I like doing the line here. If I did slope-intercept form, which I will show you a slope-intercept form of this. If I did do slope-intercept form, then I have a rough understanding of what my y-intercept should be. It should be negative, and it should be less than -1. Because here's -1 for y. It should be negative, and it should be underneath there. So now I'm going to write some equations in point slope form here. And I said some because, what did I say before? You got to choose a point to put into your equation. I only had one known point in this problem. But in this problem, I have 2 known points. And you're saying, well, but you wrote this as x1, y1, and this is x2, y2. Yeah, that was for this formula right here. It doesn't matter which known points you choose. In fact, I'm going to start with 6, 5 because it's technically easier. They're both positive. My y1 is going to be 5. My x1 is going to be 6. I can write y minus 5 equals, what's my m? 2 times x minus 6. That's going to be this guy right here. Now, if I choose 3, -1 for this one instead, what am I going to get? Let's see, what color haven't I really? Use darker blue. This one down here for 3, -1, I'll have y. It says -1, so y minus -1 is y plus 1 equals, And we're going to have m times x minus, what was this number? 3? 3 times x minus 3. Either equation is acceptable and is accepted. Both of them are the two equations for the same line. There's an infinite number of things you can do here, but choose your known points and get it started. Now, I could, this is overkill because you've solved the answer more than once, but I could have written this in slope-intercept form. And there's more than one way to get it slope-intercept form. I can think of 4 ways off the bat. One uses the graph. I'm not going to do that. I can think of 3 ways using equations. I'm going to skip one of them, and I'm going to use the 2 that are right in front of me. I can get into slope-intercept form from point-slope form. How do you figure? Well, first of all, you need some space to write. I'm going to go ahead and distribute the 2 into the x and the negative 6. So I have y minus 5 equals 2x minus 12. Now, by the way, what I'm trying to do is get it in slope-intercept form. I want to get y by itself, have no parentheses over here. So I have to add 5 over to both sides, and negative 12 plus 5 is negative 7. I get y equals 2x minus 7. So far, so good. The slope is still 2, and I got a y-intercept that was less than negative 1 like I expected to get. Now, I can do it from this equation as well using the same exact steps, the same exact idea, only I have different numbers. I still have the same 2, but the rest are different. Y plus 1 equals, let's distribute, 2x minus 6. And if I subtract 1 from both sides, I get y equals 2x minus 7. So you get the same answer no matter what. So what I'm showing you really is just this idea that there's more than one version of an answer. This one confirms what we had through the graph. Just a lot of different things there. I want to talk about a third way, but I'm going to save it. All right, so that is those problems right there. Write an equation for the line represented in the table. Now we have, these are points. I want to let you know right now, these are coordinate pairs. This is 0, 5, 4, 7, and 8, 9. All right, we have 3 known points here. Should I use point slope form again? Well, I would probably have said yes. We still have to find the slope for this thing, and I'll show you why my answer is not going to be yes when you see what I'm going to have in the graph. I already know why I don't want to do it, but I want to see if you haven't caught it yet, you will in a bit. I hope. All right, where are my 3 points? I have 0, 5, 4, 7, that's above 0, 5, and then 8, 9, double the distance away and going up right there. And it is a line. Boom. We got to go ahead and find out this slope. That's the important part. Said you could choose any 2 points. I'm just going to go ahead and choose the 4, 7, and 8, 9. I did a when in doubt, draw it out scenario. How far do I go up from 7 to 9? That's 2. How far do I go right from 4 to 8? That's 4. Clearly, it's a positive slope. The slope is 2 over 4, and that reduces to 1/2. So my slope's 1/2, and if I used point slope form, I could substitute x1, y1 here, x1, y1 here, or x1, y1 here. Any 3 equations would be fine and valid. If you want me to write the answers for you, I will, so you can check which one that you chose. I'll write them. But I'm going to do slope-intercept form. And no, I'm not going to go from point slope form to do it. Why am I going to use slope-intercept form? Well, because it just so happens that even if you didn't write these or draw this out, you hopefully got recognition that this thing right here, the value of y when x equals 0, is otherwise known as the y-intercept. If you didn't know that, I hope this graph sure gave it away. This is the y-intercept. It's at 0, 5. Your b value is 5. So when I write the equation for this thing, it'll be y equals 1/2 x plus 5. And that's it. If you catch on to the fact that you have a y-intercept, don't shy away from it. Use it. All right? Go ahead and use that thing. However you have it. If you have any of the other 3 answers, because I said I'd do that right here, this one in blue is going to be point slope form. It's going to be y minus 5 equals 1/2 times x minus 0. That was a little weird to see the x minus 0 right there. You know, you might just leave it as 1/2 x. Nothing wrong with that, but at least that's clear as day, point slope form. If I chose this one here, I'm going to do it in green. I got y minus 7 equals 1/2 times x minus 4. Remember, all these are the same equation. Different looking, but for the same line. And then this one here in purple, I'm going to have y minus 9 equals 1/2 times the quantity x minus 8. Any of these 4 work. And of course, a standard form could be put in. You want standard form? Sure. It'll be, if I do it properly with x being a positive number, it'd be x minus 2y equals negative 10. All right. We got 5 different equations for the same thing. Holy moly. There are a lot of different ways you can write this thing. Okay. Where are we now? Number 10. Which of the following points are on the line y equals 4x minus 3? Explain how you can tell. What we're not going to do is we're not going to graph this thing and then figure out, oh yeah, there it is. We have x and y values, and for something to be a point on the line, it's going to be a solution to the equation, which means if I substitute 5 for x and 17 for y, if all pans out, it is on the line, if the statement's true. So we're going to go ahead, 17 for y. Be careful here. A lot of people will put 5 for y because it's left and left. Make sure 17 goes for y here. All right, so we get 17 equals 4 times 5 minus 3. 17 equals 20 minus 3. Looks like this will pan out. 17 equals 17. Excuse me. And that's good. Explain how you can tell. My explanation's sound. Solid. In fact, anytime that I substitute these in for x and y and it makes a true statement, that means the point is on the line. A solution has a point on the line. That's how I can tell. All right, second one right here. 8 comma 28. 28 for y. 8 for x. So we're going to get 28 equals 32 minus 3, and 28 equals 29. Not quite. No, that one's not a solution to the equation. That point is not on the line. So green, I'll say yes. This one here, I'll say no. One more on C. Yeah, I definitely would not be graphing that one. 197 for y and 50 for x. 197 equals 4 times 50 minus 3. Let's check that one out. 197 equals 200 minus 3. 197 equals 197. Indeed, yes, that one checks out. So these are points on the line because they're also solutions to the equation. That's why they're solutions to the equation. Okay, number 11, Connor gets a loan to buy a new car. He needs to pay $800 at the beginning, and each month he will need to pay $400. Write an equation for the total he pays to buy the car as a function of the number of months. Okay, and I have a nice big graph to work with here. I'm like, oh, I have a nice big graph. Normally I don't spell Connor that way. Normally it's with an O, but that's all right. He needs to pay $800 at the beginning, and then each month he will need to pay $400. So when you get a loan to buy a new car, each month he will need to pay $400. So this is pays to buy the car. Okay, so I was making sure that it wasn't paying back the loan; it's paying for the car. So the whole thing, we have to label and scale this thing appropriately. There's a lot we still have to do with this problem. Okay, let's start with an equation, actually. What we're doing is everything he's going to pay to buy the car here. Y is going to represent total amount paid because X is going to represent the number of months here. Y is total amount paid in dollars, and X is going to represent number of months of paying right here. So it looks like, you pay $800 at the beginning. So that's kind of like a y-intercept. The beginning is that front part. That's the plus 800 that you get. $400 each month is going to be this part right here. So 400x plus 800 will give you it. And we can make that graph as so. Now, in order for this thing to work best, as x is number of months here, it looks like I have to scroll down a little bit. I can't fit this all as one thing because my face is in the way. X is going to be number of months. I'm going to go ahead and label these 1, 2, 3, 4, 5, 6, 7 because it looks like we're going to be hiking up pretty fast here because it's $400 a month. Now, would it be totally inappropriate, month 0 by the way, would it be totally inappropriate here to go up by 100s each time? I would say that's even too small because 1, 2, 3, 4, 5, 6, 7, 800 would be right here, and that's almost at the top of the graph, and we still have to rise 400 as we run one. Maybe we go up by 400s. Why not? Because this is 400 already. Remember, our slope is 400 over 1, and even though these are different scales, technically, if I just make this 400 right here, and this is 800, etc., every time I go up 1, that's going up 400. So I think that's going to be very good for this graph. By the way, this is dollars paid on this one as for the y-axis. 1,200, 1,600, 2,000, keep going up by 400. Don't change your scaling as you go. Yes, X and Y can have different scaling. No, you should not change the scaling per increment. I shouldn't go up 800 here and then just go up 200 each time. You know what I mean? 3,200, 3,600. And that is for Y. All right, so let's go ahead and plot this graph and use different colored green. I'm starting at 800 as the y-intercept right here. And I have to rise 400 and run 1. Huh, that's not that bad. See, that went up 400 right there. And that went over 1. Who knew that 1 and 400 would be the same distance? Not quite. Up 400 over 1, up 400 over 1, and so on and so forth. This represents my graph. Doesn't say how much the car is going to end up costing. Looks like probably more than 3,600. So assume it continues. You do want to add an arrow. I don't think I've mentioned that I've been drawing arrows every time. Look where I'm not going to draw an arrow, though. So I do have an arrow going on, continuing forever, right there. Where do I not have an arrow? I don't have an arrow at the start here. Why? Because there were no negative months involved. This was the official beginning of this thing. The domain is only for months that are greater than 0, greater than or equal to 0 here. We start at $800 and then we climb it up. Also technically, this probably shouldn't be a continuous function. I'll be honest. Maybe I can go without drawing the graph. Because, I deleted everything. Because, what? You pay on the month, right? I paid this much on this month, month 0, and this much here. So you pay on the month. Maybe you do it without it completely. I'm going to go ahead and keep it, though, just because we're doing linear equations. If we were doing sequences, that'd be a different story. Let's just make it continuously work. All right, there's that problem. Okay, so that's the end. I'm gonna let you know right now. That is the end of the linear function stuff. Everything from here on out is going to be review of previous things that I've been doing since about August. So if you want to stick around, go ahead. We are at about that hour mark there. I have 12 more. I think it's 12 more problems to do. So if you want to stick it out, go ahead. Have some fun. Otherwise, thanks for coming in here. Enjoy some more New York skyline stuff behind me. Manhattan, that is. All right, so I'm going to go ahead and keep going forward. This is algebra stuff, simplifying things by distributing and combining like terms. Let's jump straight into it, shall we? I'm not going to teach this, so to speak, as much as I'm going to do them. I'm going to show the steps. I've taught these plenty already. 24x, this equals 24x minus 18 as I distribute the 6. This negative 2 will distribute into 5x, which becomes negative 10x. And this negative 2 will distribute into this negative 8 and become a positive 16. Negative times negative. As I combine like terms here, I'm going to get 24x minus 10x is 14x. Negative 18 plus 16 is negative 2. So we get 14x minus 2. Number 13, simplify. Maybe an easier problem here. Just make sure that that negative 3 does distribute into here fully. So we're going to have 7, and then negative 3 times 4n is negative 12n, and negative 3 times negative 6 is 18, positive 18. 7 adds with 18, and we get 25. Notice that it wasn't 7 minus 18. That negative associates with the negative 12n. 7 plus 18 is 25. So I get negative 12n plus 25 there. Number 14, again, distribution here. 3 times 2x is 6x. 3 times 7 is 21. Now I'm going to distribute this negative into here. It's like distributing a negative 1 that you can't see on the outside, but it is multiplying into both of these, so it will change both of their signs. We get negative 5x and a positive 3, plus 3 here. Okay. 6x minus 5x is 1x. 21 plus 3 is 24. We get x plus 24. No other like terms to combine. All right, numbers 15, 16, 17. More simplification for number 15. So here we go. This is easier than the distribution, I guess, because we distributed to get problems like this. 8x minus 3x gives you 5x. Negative 7 plus 2 gives you negative 5. That's all. Number 16. What colors did I use? Red, blue, purple, or green, blue, purple? Number 16, evaluate for x equals 6. Okay, I have 3 plus 5 to the 6 minus 4 power. That's a hiccup. Excuse me. I am not going to do 3 plus 5 first. Order of operations. I cannot add these two together. I have to do exponentiation first. But in this exponent here is a grouping of 6 minus 4. I don't just do 5 to the 6th power and somehow do minus 4 afterwards. No, this is 6 minus 4 that actually occurs first. Pretend like it's in parentheses, if you will. This is a grouping of exponents. 6 minus 4 is 2. So I'm going to do 3 plus 5 squared. 5 squared is 25. So 3 plus 25 is 28. All right. Last one on this page here. Evaluate. Note your order of operations. Work from the inside out when it comes to parentheses. I'm going to start with the 4 plus 1. I cannot do 1 plus 2 and make 3 because 2 is multiplying with what's inside here. I cannot do 3 plus 2 right here because this 2 is multiplying by what's inside here. I'm going to do one step at a time, and I'm going to be very extra careful with it. It's possible to do mentally, but it is not possible to do out of order. Okay? You may distribute if you wanted to, but I'd rather combine like terms when I can. So for example, now I can do 2 times 5 right here, which I have to do before 3 plus 2 right here. So that's 1 plus 2 times 3 plus 10. Now I have 3 plus 10 in here. So that's 1 plus 2 times 13. Now I do 2 times 13. That's 1 plus 26. And I get 27. Like I said, it's possible to do some form of distribution. I would caution myself with it. You have to add at some point anyway. Might as well do it when the numbers are small and within reason. Okay. I did this next, by the way. Okay. Moving on. I think 6 more problems. Solve 11 over x equals 7 over 2. This is a proportion. Cross multiplication is in play. I sure hope you know what it means when I state cross multiplication. If not, it's best that you don't use it and find another form. Multiply both sides by 2 and multiply both sides by x. 22 equals 7x. If I divide both sides by 7 here, simply x equals 22 over 7. I'm not going to round it. I'm not going to write it as a mixed number. I am fine how it is. I love that answer. I love that answer, and I'm not joking. I do. As far as how to write it best. By the way, this actually, well, you know what? This is an approximation of pi. You know what this rounds to? 3.14. I don't know if there was intent by the content creator of this. This was one of my, what do you call them? Colleagues. One of my department friends. X plus 5 divided by 4 equals 14. There are 2 different ways you can do this problem. Both of them hold merit for different reasons. One of them you have to be uber careful for, even though it's the method that I almost like to go to more often. And the first one that I want to mention is, what if I multiply everything by 5? I don't like the fraction here to begin with. I don't want the fraction in my life. So what if I multiplied everything by 5? And that's fine. The problem is, make sure you multiply everything by 5. Don't just do 5 over 5 and say it's gone. This 5 better distribute here and cancel. And the 5 better distribute into the 4 as well. So if I multiply everything by 5, I get just x, because 5 over 5 is 1, plus 20, not x plus 4, equals, and 14 times 5 is 70. Subtract 20, you get x equals 50. That's one approach there. You can do that as one approach. The second approach here is by leaving the fraction as is and then going ahead and dealing with the 5 later. Subtract 4 from both sides instead. So instead, we say, hey, let's do minus 4 from both sides. I do not want to use blue for that. Hey, let's do minus 4 from both sides here. And we're going to go ahead and get, what is it? X over 5 equals 10. Now I multiply both sides by 5 to solve at this point, and you get x equals 50. I can see why most people might see you want to do the right side instead there, as long as you understand if it divides by 5, multiply by 5 in the end. But if you had to deal with more fractions than just this, get rid of them as fast as possible. That's me. All right, the last one here, we have 5 minus the quantity 2x plus 4 equals 17. Let's simplify this side of the equation first. There are other ways to do it, but let's simplify this. Let's combine like terms where we can, distribute the negative, do all that. 5 minus 2x minus 4 equals 17. Remember, that will be a minus right there. 5 minus 4 is 1, and I have negative 2x plus 1 equals 17. All right. Got to solve for x now. Subtract 1 from both sides. That seems appropriate. We get negative 2x equals 16, and divide by negative 2, you get x equals negative 8. I'm not double checking any of these. Feel free to double check and make sure that my work is right. Make sure you know how to double check things like that. All right, I think these are the last three. Take my word for it. I think they're the last three. Solve this equation. I have x's on opposite sides of the equation. The goal is to get x by itself. I like to make my x's positive just because. There's no rhyme or reason to it. I just do. So I'm going to subtract 6x here from both sides. And I'm going to go ahead and have 3 equals 18 plus 3x. Subtract 18 from both sides. And I'm going to go ahead and have negative 15 equals 3x. Divide both sides by 3. And we're going to get x equals negative 5. Now I brought my x to the left side of the equation instead there. Okay. Second to last problem. Solve 2 times 4x and 2 times negative 2. I get 8x minus 4. Here's the minus 3x equals 7x plus 16. Yes, I'm going to get my x's on one side of the equation, but I first want to go ahead and simplify this left side. I have 8x minus 3x, and that gives me 5x. 5x minus 4 equals 7x plus 16. Okay, let's start moving some things over. See if you can do this mentally with me. I'm going to subtract 5x from both sides. Again, I want to make it positive. That's me. Subtract 5x from both sides. I'm going to get 2x on this side. 5x is gone. And subtract 16 from both sides here. Negative 4 minus 16 is negative 20. So I get 2x equals negative 20. Divide both sides by 2. I get x equals negative 10. And finally, solving this last one here, 9 minus 2x equals 17. I'm going to go ahead and subtract 9 from both sides right there. And I get negative 2x equals 8. Divide both sides by negative 2. See, that's one of the reasons why I like to get my x terms positive. You know how many people just divide by 2? You need to make x positive here. So you got to divide by negative 2 there, which of course changes this sign. Negative 2 times what number is 8? Well, it's negative 4. X equals negative 4. All right, that was a lot of simplifying and solving. Looks like nothing else to that as far as review goes, but make sure you're feeling pretty good with that review. All right, so that ought to do it for this video right here. That is all that I got. Hopefully that review of the lines took care of things pretty well. Solved some equations there at the end. My name is Mr. Robinson. I am, stick around for another video to come up soon at some point. I'm going to be recording another one on a cumulative review, much longer. Goodness, a cumulative review of everything that I've been teaching here since August. And it's going to hit a lot of different things. So if you want to get a longer video that covers a lot more, you want to get some review, feel free to stick around. So that ought to do it here. I'm Mr. Robinson, signing off.